Welcome to my summer 2022 Math 302-601 course. My name is Robin Sanders and I'm the person behind all of the videos and all of the assignments that you'll be doing this summer for the completion of this course. I want to tell you a little bit about myself, and then I want to tell you a little bit about why I think this is an important course for math majors and Masters of Mathematics Education students to be taking in the course of their degree program. I completed my PhD at the University of Illinois at Urbana-Champaign a long time ago. My research specialty was in algebraic geometry, and my family and I moved to Buffalo in 1997 for a tenure track position here at Buffalo State College. And I've been teaching here ever since. And I teach everything from our freshman general education courses all the way through almost all of the math major courses, and many of the mathematics courses for the mathematics education majors. Since moving to Buffalo, I have to say that when we came here from Illinois, we would kind of surprise native Buffalonians by telling them that the weather got better. I love Buffalo winters. We ski in the wintertime. I garden in the summertime. I do a lot of hiking anytime I get a chance to do hiking. And my husband and I also like to do a lot of biking. And Buffalo is very good for all of those kinds of activities. Now let me tell you a little bit about why this is an important course and why I think it's a good course for math majors and mathematics education master's students to be taking. What Math 302 and 601 is really all about are fields and rings and something called Galwa Theory. And of course, those phrases probably don't mean very much to you, so let me tell you about where this stuff comes from and why it's important. I want to start by having you think about the quadratic formula. We all know the quadratic formula. We learned it in high school, and for those of you who are high school teachers, you probably teach it. The quadratic formula gives us the exact roots of any quadratic equation in terms of radicals involving the coefficients of the polynomial. And I know that when I was in high school and was first introduced to the quadratic formula, I really wondered, can the quadratic formula be generalized? In other words, is there a formula that would let me find the roots of any cubic polynomial or any fourth degree polynomial or any fifth degree polynomial in terms of radicals of its roots? Well, it turns out that in the 1500s, a mathematician by the name of Girolamo Cardano did find formulas for the cubics and the quartics. Now, we don't teach them in high school because they're fairly long, they're fairly complicated looking, and they're not real useful in the sense of being able to be memorized and plug in numbers real quickly. But they do exist. That's the thing that I want to stress. Cardano actually had to invent imaginary numbers in order to figure out how to do these formulas, how to describe these formulas. But he couldn't get anywhere on the fifth degree polynomial problem. And the problem sat open for several centuries. And in the 1800s, a mathematician by the name of Everest Galwa came along, and Galwa settled the question. And he settled the question in the negative. In other words, Galwa was able to prove that there is no formula that will solve every fifth degree polynomial. And in order to do his work, in order to prove that there was no formula that would solve every fifth degree polynomial, Galwa basically invented what we now call abstract algebra. He invented groups. He was the first person to really study rings and fields from a rigorous axiomatic point of view. And we put everything together into something that we now call Galwa Theory, which ties everything together and answers the question that some fifth degree polynomials cannot be solved by radicals. And that means there is no way of finding a formula that will solve every fifth degree polynomial. This course, we're going to study the abstract algebra concepts that we need in order to understand Galwa's work. And by the end of this summer term, the goal is for you to understand enough abstract algebra, ring theory, field theory, to have a basic understanding of how Galois theory is put together and why there is no formula that will satisfy every fifth degree polynomial in terms of radicals of its coefficients, and hence why there is no generalization of the quadratic formula. I hope you're ready to start an adventure, a mathematical adventure, and stretch your mind on some ideas that you've never looked at before. And if you are, then welcome to the course.